Once the structure has been calculated, we can consult the general diagnosis. The diagnosis, through a series of messages, indicates all the problems that may exist in each structure or specific parts of the structure. When the analysis, as in this case, is empty, it means that all the checks carried out by the software are positive. In addition to the calculation, we need to consult global and local data to understand well the structure's response to the different actions. The overall results can be viewed in the 3D view via the 3D results toolbox. So we can consult the views that summarize, for example, the distribution of the load in the building. Through the representation of the chromatic scale, we can immediately identify which are the elements with more loads. We can also consult the displacement, such as the displacement by the gravitational actions. We simply activate the load conditions, and in this way we can see the displacement by the effect of the gravitational loads. The displacement here is shown considering the characteristic actions of the loads. So if we activate different load conditions with their characteristic values, we can consult the combined deformations. In the same way, for example, we can see the displacement by seismic actions across the x or y directions. We can see the stresses, for example, the actions of the bending moments due to gravitational loads. For this we reactivate the fields of each load action and the chromatic scale. The chromatic scale automatically shows us of the element with its stress, but we can also eliminate the representation in the chromatic scale and see the classic stresses diagram. Again, these are characteristic stresses, and not a combination of stresses due to loads. We can select a single element, and a window is dynamically hooked to the cursor that allows us to control how the stresses varies, such in this case, the bending moment along the axis of the element. As for the geotechnical part, for example, we can consult the soil strain and, as before, both static actions and actions produced by an earthquake. Therefore, through this list, we can consult the overall results that affect the entire model. We can also consult the local results. For example, we select a beam and on the right, in the Properties toolbox, we find the Properties and Results tabs. If we activate the Results tab, we can activate the type of result that we are interested in, such as stresses, or directly consult the verification. In this case, the software identifies several sections in the element, and for each section offers the N and M data that compared to flexopressure has generated the lowest safety coefficient. We can consult the verification for shear, torsion, cracking limit state, or the operational tensile stress at limit state. We can also visualize everything available from the calculation tables. In fact, in the navigator tree, we find the results of the calculation node, and, from this list, we can choose any result. For example, we can ask the program to show us the verification of the compressive bending for the columns. This document is what we will find in the calculation tables, for each column, the stresses, the moments, the safety coefficient, and so on. But apart from the calculation, the program has arranged reinforcements in all the structural elements. Therefore, from the navigator in the reinforcement sheet, we can consult the reinforcements of the different column. We will see the indications of the bending zones, the criticisms at the extremity, and all the indications of the reinforcement and its arrangement in the structure. Similarly, selecting a beam and clicking the right mouse button opens a local menu from which you can access the reinforcements view. At this point, the proposed reinforcement can always be modified. The structural engineer, for example, can add a bar and give it a curvature that will contribute to the verification of the cut. Once the reinforcement has been modified and through the Confirm button, it is possible to dynamically modify the reinforcement verification. This is valid not only for the modified element but for the entire structure. In this case, the software is telling us that by adding this bending steel, the beam has become too rigid and resistant to bending, therefore it is no longer protected by rapid plasticity. The diagnosis in real time gives us the error alert. The structural engineer at any time can access the result and the 3D view of the element and request a second calculation for such single-element reinforcement. Therefore, from the toolbox of the column reinforcements, it is possible to request the software to recalculate the reinforcement only of this column. If we go back to the diagnosis, the error message has disappeared after the calculation. Now the drawings are available, so we have the plans of the structure for all the levels. We can export them at any time in the CAD format. We can also organize the construction documents, thanks to the Plan Assistant. We can automatically generate the construction documents or create it manually. Within the construction documents, we can drag all the plans we need. In this case, we are dragging the plans of the structure, and we specify the scale factor. We can also drag the plans of the reinforcements within the construction documents. In addition to the reinforcement or structural plans, the program offers us the calculation report. With a double click we open the file to start with the composition of the report, and obviously in the report we find a summary of our project, which are the reference regulations, the materials used with their technical characteristics. With a right button click over the document, it is possible to export to RTF file format, giving the possibility to manage this technical report with any word processor. In the same way, we can see the calculation and geotechnical report as well as the measurement report and the bill of quantities. In fact, within the EdiLus software, we have the Primus integration. With a double click we automatically get the estimate of the different elements of the structure, such as the cubic meter of cement, kilograms of steel and so on. If we open for example the steel node we see the distribution of steel,